Hi everyone, welcome back to SMS Tech Desk. So, are you a VMware administrator struggling to clear VCF admin interviews? Maybe you have 3 years, 5 years, or even 10 plus years of VMware experience, but you are still finding it difficult to answer VCF questions in the current market scenario. So, in today's market, many companies are moving towards a VMware Cloud Foundation and expecting candidates to have a VCF knowledge along with VMware administration skills. So why are many VMware administrators getting rejected in the VCF interviews? What skills are companies looking for? And how can you successfully move from a VMware admin role to a VCF admin role? In this video, let's understand the reasons behind these interview challenges and what you can do to overcome them. Let's get started. Many VMware professionals know vSphere, vCenter, and virtualization very well. But when interviewers start asking about VMware Cloud Foundation, NSX, vSAN, Workload Domain, SDDC Manager, VCF Architecture, then Lifecycle Management in VCF, and some real-world deployment scenarios. In today's market condition, many candidates finding it difficult to answer confidently. As a result, they are facing rejection after rejection in the interview. That's exactly why SMS created this interview preparation program for VCF. Our goal is very simple. We are going to help VMware administrator successfully transition into a VCF administrator role. So we don't focus on theory alone. Here you will learn real interview questions, real world scenarios, troubleshooting discussions, and architecture concepts. And here also we are going to cover deployment workflows and hands-on lab experience based on what companies are asking today. So this is not about the normal training, whereas there could be an 12 module training program for install, configure, manage. No, this is completely about interview preparation. Like suppose now you are working as a VMware admin, immediately want to switch over to VCF career. So how we are going to prepare for the interview? So completely an interview preparation program. So stop losing opportunities because of interview gaps. The market is moving towards VMware Cloud Foundation. The demand is growing. Now this is the correct time to upgrade your skills and your career. So join SMS interview preparation program for VCF. Prepare with confidence, clear your VCF interviews, and take the next step in your career as a VCF administrator. So SMS is going to help you from VMware admin to VCF admin. We make it happen for candidates. This is a real world full track topology that we use as a part of our VCF interview preparation program. In this session, we're not going to discuss the theoretical concepts of this rack topology. Instead, we'll focus on how a VMware Cloud Foundation private cloud is designed in a real production environment. Now, let's look at how rack level redundancy is implemented, why it is important, and how organizations design their infrastructure to avoid a single point of production in the production support. These are the types of real-time architecture and design questions that are commonly asked in VCF interviews for VCF admin and VCF architects. So let's get into the topology and understand how rack level redundancy is designed in a VMware Cloud Foundation private cloud environment. If you look at this topology, we can see 4 independent racks, right? Rack A, Rack B, Rack C, and Rack D. The first thing we should understand is that the workloads are intentionally distributed across all 4 racks. Here, we do not place all servers of a particular cluster or workload domain inside a single rack. If you do, like if you place, for example, we have production domain. If you place all the production domain servers in a single rack, then that's going to be a single point of failure. Okay, so in production we have 16 servers, right? So if all servers are sitting on the same rack, if that rack lost power, cooling, or network connectivity, or experienced a complete hardware failure, the entire workload would disappear instantly from the VCF. So if you want to, provide redundancy, then we need to follow some, like redundancy model for VCF from the real-time perspective. So here we distribute server across multiple racks so that the infrastructure can tolerate a complete rack outage without causing a complete service outage. This approach is called technically fault domain design. Okay, so fault domain is simply a boundary wherein failure can occur. Uh, in this architecture, every rack becomes an independent fault domain. If one rack fails, the remaining racks continue operating in the production support. Now, let us move upward and look at the networking architecture, designed for this topology. So every rack contains top of rack switch, which are also called leaf switches. One common misunderstanding is the rack A's leaf switch directly connects to rack B's leaf switch or rack C's leaf switch. That is not how a spine leaf architecture works in the real-time production support. There are no direct connections between leaf switches across racks. Instead, every switch connects upward to the spine layer. The spine switch from the high speed backbone of the data center. It passes the communication from one rack to another rack. For example, if a workload inside rack A wants to communicate inside rack B, the traffic will flow like this. So server in rack A goes to the leaf switch. From the leaf switch, the traffic move upwards to a spine switch. Then the spine switch forwards the traffic down to the destination leaf switch located in rack B. Finally, the destination leaf switch forwards the traffic to the target server. This is the standard communication model in a modern data center. Now, let us look at that rack level latency. Suppose two servers are located inside the same rack. The traffic stays local to that rack's leaf switch, the path is shorter and the latency is extremely low. Now suppose one server is located in rack A and another server is located in rack D. The traffic must travel up to the spine layer and the back down to the destination rack. Although the path is slightly longer, modern data center switches operate at extremely high speeds with 25 GB server connectivity, 100 GB, sometimes like 400 GB spine uplinks also there. So here the additional latency is usually measured in microseconds. So in real production environment, this difference is negligible. The benefit gained from lock level redundancy is far greater than the tiny increase in the network latency. Now let us discuss what happens during a rack failure. Imagine rack B completely loses power. So every server inside rack B immediately becomes unavailable. The top of rack switches inside rack B also becomes unavailable. However, the rest of the infrastructure remains operational, whereas rack U continues functioning, rack C continues functioning, rack D also continues its function. Their leaf switches continues forwarding traffic to the spine layer. The spine switches continue operating normally. The network fabric remains intact because the failure is isolated to a single rack fault domain. This is exactly why workloads were distributed across multiple racks instead of being concentrated in one physical location, that is one physical rack. Now let us focus on the maintenance activity. See, these are the scenarios. Possibilities are there. One rack might go down in production, not all racks at a time. That's a very rare scenario. Now let's focus on maintenance activities. In enterprise environments, hardware maintenance happens regularly, right? For example, if you take a rack D, we can say hardware maintenance happens regularly, firmware upgrade happens, switch replacements happen, power maintenance happen, then cooling maintenance happens inside the data center. At that scenarios, if all servers were located in one rack, every maintenance activity would create a business risk. But when workloads are distributed across multiple racks, we can safely perform maintenance on one rack while the remaining racks continue servicing applications. Improves the operational flexibility, and another important concept is capacity planning. So from the real time perspective, when you design rack level redundancy, we should never assume all racks will always be available. Instead, we assume that one rack could fail at any time. Therefore, the remaining racks must have sufficient capacity to absorb critical workloads during a failure event. This is one of the reasons why enterprise environments always maintain the spare capacity. So finally, when you step back and look at the complete rack architecture, the biggest achievement of this design is not the number of servers, switches or domain. The biggest achievement is the elimination of rack level single point of failure. So every rack operates as an independent fault domain here, and every rack has redundant network connectivity. Every leaf switch connects upward to the spine layer, and every inter-rack communication follows the predictable path of leaf to spine, spine to leaf. And workloads are distributed across multiple racks. The infrastructure can continue operating even when an entire rack becomes unavailable. I hope you got an understanding on the full rack topology and the rack level redundancy from the real-time perspective. So this is what I expected in the interview. Suppose if you are a VCF admin, you have to explain a scenario like what is the rack level topology design which you followed for your environment, because in VCF we have 4 rack level models. Okay, out of that 4, which rack level model you chosen for your environment? In that case, we should be in a position to deliver like what is the rack model which we used in our environment, which I supported. Okay, so we'll proceed with the next topology.